All right, so we're going to look at the probability of independent and dependent events. And so we'll see the difference between the two and then how the probabilities are just a little bit different. So independent and dependent events, we're going to be multiplying probabilities together. So we want to remember the difference between when we're supposed to multiply and then when we're supposed to add and subtract. So remember adding and subtracting we did yesterday. We're looking for the word or. Okay, so when it's an or problem, we're adding and then try to subtract off anything that's in common. All right, so independent events are the probability of event A has no effect on the outcome of probability of event B. So for example, we toss a coin twice. The outcome of the first toss, could be heads or tails, has no effect on the outcome of the second toss. Okay, so I can flip a coin, I get heads the first time. I flip it again, I get heads the second time. Flip it again, third time, it's heads again. There's no guarantee I'm going to get heads the next time, right? Because each one is separate from each other. They're independent events. So in that case, when they're independent and one has no effect on the other one, we just multiply the two probabilities together. So we find the probability of the first and the second, and we multiply them together. Now, you can have more than two. So you could, find the probability of getting heads 3 times in a row, right? And so you find the probability of getting heads the first time. So that'd be a 1/2 chance. Probability of getting heads the second time, that's a 1/2 chance. Third time, 1/2 chance. And all find together. Okay. Now, dependent events is a little bit different. The probability of the first thing happening is going to affect the probability of the second. All right. So, for example, finding the probability of picking an ace from a deck of cards, not putting that card back in the deck, and then picking a queen. All right. So we know that the probability of picking an ace is a 4 out of 52 because there's 4 aces. We know that the probability of picking a queen is also a 4 out of 52 because there's 4 queens. But if I assume that I pull the ace out and I don't put it back in the deck, there's not 52 cards left in the deck, there's only 51. So the probability of the second card being picked to get a queen is going to change because I didn't put that first card back in. So the first probability is affecting the second. All right, and so when they're dependent on each other, the probability of the first happens just like we do normally, but this is the symbol right here. It's not a fraction bar. It's just saying that the probability of A is affecting B. Right? So the probability of A is affecting B. All right, so that's just what that symbol is. All right, so let's look at these examples to determine if they're independent or dependent on each other. All right, so A, your test grades and your final semester grade, are they dependent on each other or are they totally independent, separate? Is your semester grade dependent on your test grades, what you get, or are they just totally separate? They have nothing to do with each other. Yeah, they're dependent, right? Because what we get here is dependent on what we get here. Okay, your test grades, if you have all A's here, then your semester grade is A, right? So this grade right here is being affected by what you do over here. All right, so they're dependent on each other. Put D. D for dependent. All right, B, selecting a red marble, then a blue marble. So we're picking 2 marbles from the bag. There's 2 blue, 5 red, without replacing the first marble. All right, so I take that blue, the red marble out. Okay, I select it, and then I don't put it back in the bag. And then I want to pick it, the next one. Okay, they're dependent on each other. Okay, so they're dependent. Because the second event is going to change of what it should be. Because there's 1 less marble in the back. All right, see, selecting a blue marble, then another blue marble from the bag, and we replace the first marble before we pick the second. All right, so this is independent, okay? The first pick of the marble is not going to affect the second pick. All right, and that's because we put that same marble back in. So we're looking for replacement and non-replacement of marbles and cards and stuff like that. All right, so let's do this first example. We spin this money wheel, and we want to find, we're going to spin it twice, and we want to find the probability that you get more than $500 on your first spin, and then go bankrupt on the second spin. All right, so what happens on the first spin has no effect on what's going to happen on the second spin. They're totally independent of each other. All right, so we're just going to find the probability of each one, and then we multiply them together. All right, so the first thing we got to do is figure out what our sample space is. How many total spaces are there? All right, and so we go around and just count how many spaces there are. I think there's 24. All right, so I think all the A's, they're already labeled for you to get more than 500. So there's 1, 2, 3, 4, 5, 6, 7, 8. All right, so you have an 8 out of 24 chance of spinning the first wheel and then getting it more than $500. All right, and then we're going to multiply this. Find the probability of going bankrupt. And so it looks like there's 2 places that you can go bankrupt on. And so that's a 2 out of 24. All right, and then we can go ahead and multiply those together. It's up to you how you want to do this. You can throw it in a calculator, let it do it for you. You could simplify first. Looks like 1 out of 36. And then let's go and practice finding the decimal also. Let's see. So we'll go 4 decimal places because I think there's a couple problems on the homework. You're going to do that. 0.0278. So that's a 2.78% chance of that happening. Okay, so it's a pretty small chance. All right, example 2. We're going to look at a deck of cards. Find the probability of selecting an ace, then a red king, without replacing the first card. Right. So here, those are the key words, without replacing. All right, so we're going to first find the probability of getting an ace. So there's 4 aces, so 4 out of 52. Times. All right, so I have to assume I pulled the ace out, and I don't put it back in the deck. All right, and now I want to get a red king. All right, so how many red kings are there? There's 2. There's the king of hearts and king of diamonds. But there's only 51 cards left in the deck because I have to assume I pulled the ace out and didn't put it back in the deck. All right, and so then I just multiply those together. All right, so it's 2 out of 663. And we'll give the decimal also. 0.003. So it's a 0.3% chance. So it's not even 1% of that happening. All right, example 3. Find the probability the first card that you pick from a deck of cards is not a face card. And then the second card is a face card. You replace the first card before selecting the second. And then you do not replace the first card. All right, so the first thing we got to do is find the probability the first card is not a face card. So how many cards are in the deck that are not face cards? Well, how many face cards are there? How about that? There's 12 face cards. Okay, so we know there's 12 face cards. How many cards would not be faces or face cards? 40, right? So it's a 40 out of 52 chance of picking a card that's not a face card. All right, so it says before you pick that second card, replace the first card. All right, so the second card, we want it to be a face card. And so then it's a 12 out of 52. We can just multiply those together. So 30 over 169. And we'll just leave with fractions from now on. Should know how to convert to decimals. All right, and then part B, you do not replace the first card before you pick the second. So the first probability is going to stay the same, 40 out of 52. All right, so then the second probability, there's still 12 face cards in the deck, but only 51 cards to pick from. All right, so 40 out of 221. All right, so now let's look at example 4, marbles. So we have 4 green, 3 blue, and 2 red marbles. Part A, what's the probability of picking a green marble, replacing it in the bag, and then picking another green marble? All right. So the first thing we got to do, our first pick is a green marble. So what's the probability of picking a green marble? 4 out of 9. 4 green, 9 total marbles. All right, we're going to take that green marble and we're going to put it back in the bag. Okay. So replacing and non-replacing are the kind of the key words there with marbles and cards. So we're multiplying. All right, and so we put that green marble back in the bag and we want to pick another green marble. So it's the same probability, 4 knights. All right, and then we can multiply those together. It's at 16 over 81. All right, part B, what's the probability of picking a green marble, not replacing it, then picking another green marble? All right, so it's still, first probability is a green marble, so 4 knights. I take that green marble, leave it out of the bag, and now I want to pick another green marble. So what would the second probability be? 3 out of 8. All right, so there's 1 less green marble, only 3 green marbles, and there's 1 less total marble in the bag. So 3 out of 8. All right, and then we'll go ahead and multiply those together. This is pretty easy to just do it without a calculator. All right, part C, what's the probability of picking 3 blue marbles in a row without replacing any of them? All right, so see if you can set that one up and find the probability. All right, and then D, what's the probability of picking 3 blue marbles in a row? You're going to replace each marble that you pick before you pick the next one. All right, so here it's just 3 knights times 3 knights times 3 knights. So each one has the same probability. So 1 over 27.